why it doesn't. Okay, today we are going to have our lesson 5. Last time we discussed about what function templates are, and we had one exercise. We solved one exercise on function templates, and we also learned about template specializations, and we solved one example, one exercise also for that. Then we discussed about standard template library, different containers, how to handle the error, different algorithms, lambda functions, smart pointers, and the last two things that we discussed was header guards, and we learned how to add a library to our project. I will upload. I think I can do it after this lesson. I will upload one video for you. You don't need it for your first part of the project, but if you want, you can use. I mean, it's not necessary for. I mean, it's not a requirement for your project. But if you want to add a Boost library, I will upload one video for you and share it with you after the class. In that video, I explain more, and I mean every steps that you need to download. You need to do to download the Boost library and add it to your project has been explained and recorded. Today we are, if you remember, and I hope you have done it at home. I gave you some exercises last week. And today we are going to solve them. You already have the answers, but we are going to discuss about that in line by line. The next topic that we are going to talk about is reading and writing from files and parsing strings. And we have a quick overview, quick review over regular expressions. And the last thing that we discussed about is our classes, for which we discussed about some topics: constructors, copy assignments, destructor, static variables, and members. By the end of this lesson, you will have all the things that you need to implement your project. I've heard from your friends that they have done it already, so it's a very good piece of news. But for people who didn't have C++, any knowledge, any experience with C++, now you have all the things that you need to know for writing the first part of your project. I mean, by the end of this lesson. And you will have 2 weeks to do your project. And from the next lesson, we will discuss about the topics that are needed for you to learn, because you are going to also do another project after this one. So the exercises. The first exercise that I gave to you was defining a variable to store people's ages. And I asked you to initialize this variable by 10 different ages, ranging from 1 to 10, then transform all the ages by adding them with 1. So as I said, you have the answer, but I want to ask you to know what is your guess? If you have done it at home, which library have you used? I mean, which container have you used for this exercise for the first?
I tried it with an array. No, sorry, with the vector, because it's you can elongate. And I use the vector.
Yes, correct. Because we can use arrays as well, but arrays are more CSI CSI way of coding. So we don't like that, and they are, okay, we know here that they are, for example, here I said that initialize this variable by 10 different ages, but I didn't say that these are the whole different people that we will have. So we may have more persons. So with arrays, you cannot increase the length of the array. You define it, you initialize it by that, and it's fixed. But in using vectors, you can change its length during the run of your program. So yes, as your friend said, we will use we'll use a vector of integers, and since we know, okay, at least we will have 10 different ages, so we set the size to 10, but it doesn't mean that, as I said in the last lesson, it doesn't mean that it's fixed. It can grow, and also it can have less members than this. And to initialize this variable by 10 different ages, since it's ranging from 1 to 10, I'm using this algorithm from a standard template library. You can also use some for loops, but since it's exactly what this algorithm is doing, so I use this one. I hope that I know that this one is optimized more than my code. And I ask you to transform all the ages by adding them with 1. I haven't taught you, for example, what this algorithm is doing, but as I said in the last lesson, we cannot cover all the algorithms existing in standard template library. We cannot cover all the containers in this course, but they are very similar to each other. And when you hear something like this, just Google and try to find the best answer for that. And after some time, you will have the experience to choose them by your heart. So for transform, it's a function that starts from the begin and end of the start and end of one vector. And I'm saying that transform every item of this vector and write it into the same vector. So I'm giving the start of the same vector to that. And this is just one lambda function. And why it is passed by reference? Because we know that we want to change it here. And I haven't passed any other thing here because I only want to change the items. I don't need to have access to other variables that have been defined before this transfer. So this is, and as you can see, similar to other algorithms like findif, like copy that we saw in the previous lessons. Again, we are working with some pointers of our containers. And so the structure is very similar. We have one lambda function, we have iterators, and an algorithm is working on the items. So how about this one? What is your guess, or what did you do at home to have, what is the container that you define here? The question is that define a dictionary for ID and name of people. Define a function taking this dictionary and an ID and printing the name of the person with that ID. My first question is that what is the type of container that you use to store this data?
Personally, I use the map because of the key value pairs.
Yeah, correct. Because we know that this is just one ID, and it means that, so It means that we know, first of all, I can see from dictionary that it's a map. Dictionary, as I said, maps are very similar to dictionary in Python, but their name is different, but they are the same, but their functionality might be somewhat different, but they are really like a dictionary. We have some key and we have some values. And we know that the key is unique here. As I said, it's ID, so it's unique. So we can have one map, as you can see here, but for ID, I define an enumerator class. And as you can, I think you can also have something similar to this, not exactly this, but something similar to this for your project, because you have different data members in your files, in your the file names, and all of them can have some ID. So, and the user can access to them using their IDs. These are different ways of designing your program. I'm not forcing you to do this, but it's a good way of implementing your project. So instead of, for example, here, the user wants to add one member to this human list, it doesn't have to write, he or she doesn't have to write some numbers, because, you know, entering some numbers can be can lead to some bugs. So it's not really recommended. And when we have some IDs like some numbers, it's better to define some enum class for them. And then the user and you yourself will work with those enumerator constants, instead of working with those values that are very prone to be to become a bug. So as the dictionary, let's first go here. As the container, I use a map of human ID and a string. String is the name of the people, and human ID is the ID of the people. So I have one dictionary for that, one map for that, and I can add some items using this structure. So I'm writing ID names Nastan, and the name is also Nastan. So this is just one example. So probably you will not have such a thing in your project. Probably you will have one class for your people, because people have more data members and more function members than these two. But here it's just one example to work with data container. And in that case, you will, instead of having one string here, you would have one class and one object. So, but here it's just one string, and I assign that string to that one, to this key. And I call one function with that ID, and I'm going to print the name of the person with that ID. What is the function here? The function is getting that container, but as const reference. Why? Because we're not going to change this list, and we know that it's getting much memory, so it's not good to copy that. So because of that, we send it by const reference. So, and the ID is just that enumerator constant. And here I'm defining what const iterator. Again, I haven't taught you what is const iterator, but it's similar to any iterator. The difference here is that you could work with other things, but here I gave you this example. I mean, I solve it like this to let you know, to get familiar with other iterators, but this is something you yourself should do it as well. With const iterator, we have one pointer, but it's a safe pointer, like a smart pointer, that we are working with every element of that iterator, that container, sorry, that container. But we cannot change its value because it's const. And I'm not going to change them. So since I'm not going to change them, I define const. I should not give if I know I'm not going to change something, I don't give access to the user to change it. For example, I know this function is not going to change human list, so I will not send it by reference. I will send it by const reference. Here again, I'm not going to change elements of human list, so I will not use a regular iterator. So here I'm using find to and find will check all the keys in the map, and it will find the first occurrence of that one. And if it doesn't find that, it will return a pointer to the end of that list. What I'm doing here, I'm comparing and assigning in the same line. And it's very common in C++ to do something like that. I could write this one here, equals human find, and then check itr with this one here in this if. But in C++, you can do this, something like this. You can do what you are doing here. It will first assign this one to this one, because I also put a parenthesis here. And the result of this one, which is a pointer to that item, will be compared with the end of this iterator. So if it is not the end of the iterator, if it is found, then I have a pointer to that element. But we know that that element is a pair. As I said, elements of map, items of maps are some pairs of some, for example, here, pair of human ID and a string. And to access to that element, we have used first and second. Here, I want to access to, sorry, I want to have access to the second one, which is the name of that, because I want to print the name of that person. If I wanted to print the ID of that, I had to use here first, itr this first. The difference between this one and dot is that I have here a pointer. When I have a pointer, I use this operator to access to that element. But if it was not a pointer, for example, if we were in a for loop and we were iterating over the elements of this one, as I explained in the last lesson, then I had to use itr dot second instead of this one. So when we have a pointer, we know this is our operator. So the last exercise was to define a variable. Let me check something here. I don't know why I hear some noise and it's very strange. All of you are muted, but I hear some noise. Okay. To define, the last exercise was to define a variable to store students' information. Students what are the students' information? What is the students' information? Students have a name and a list of scores. Define a function taking this information and a score index to print the score of the students for the given index. What was the container that you used for this one? Do you have any guess, or have you done it at home?
Yeah, I tried, but I still was exploring. But I thought maybe a map to have the students and then grade points allocation, but the value parts of the map should be a vector then to hold the multiple grades.
Yeah, correct. But the problem here is that now students, if you use map, you should have unique IDs. But the students, I mean, their name is not unique. If you use name as the key, then it's not unique. I mean, you may have two persons with the same name. So in that case, we cannot use map because we don't have any unique key here. So instead, I'm using, let's come here. I'm using a vector of pairs, and the pair consists of one string and one vector of float. So as you said, the value for that would be a vector of float. So these are the scores, the list of our scores, and the name will be stored in the first elements of our pair. Why don't I use map here? Because as I said, name is not unique. If you use map, if you enter, for example, one item with the name Nassan and add its scores, and there is another person with the same name, and if you add the score, it will overwrite that. So then you will lose the score for the first student. This is not, I mean, this is just one example, so it's not really good. I mean, in rare cases, you will have to use such structures, but it doesn't mean that for when you have some people, you should do something like this. When you have some people, probably you have some IDs. Also, or you can define one IDs for them, and you will probably, your people, your students have more information than just having some scores. And then it's not really good to have many containers here to be able to store them. It's better to make it more clean, to define one class, one object for that. And but in such a cases that you don't have any ID and you don't want to overwrite them, then you have to use vector of pairs. And you should know that now, since it's not a map, it's not sorted. For a map, when you, no matter how you will add your item, how you will push your item to your map, they will be sorted, so based on their keys. But in vectors, this is not the case. So even if you are using vector of pairs, they will not be sorted. And the order is based on the order that you added them to your vector. Okay, I defined this one as our container, and to add some items to this vector, I'm using pushback, and it will add one item to the end of that vector. And you can have some other things. Try to work with, for example, with employee spec or with back. I mean, these are not these two things that I'm saying here is not something very useful for this exercise, but in some cases you may need that. So work also, exercise also with those things. So I'm going to add one pair to this vector. How can I create that pair? As I said in the last lesson, we can use this structure, cd make pair with this type, and then I have one parenthesis, the first element Nassan, and the second element vector of floats. There are other ways to add these things, but these are, I mean, this is the best thing that we could do here for this exercise. Again, I can add another item like this, and now I'm going to print the score of that, one score of those students with this ID. So I'm saying that print these two for me for every student. So the function gets again one student's length, as the exercise, I mean the definition is saying, we're not going to change anything. We are just having access to them to read from that container. So because of that, again, we are using const reference. The type of this one is size T because we know that in a standard template library, indexes are of type size T. And if I put integer here, then I will have warnings. So I'm saying if a score index is less than this one, return false. As I said to you, to handle the errors, there are different ways. You can handle the errors by passing, by returning some integer values. You can handle the error by returning or updating some enumerator constants, the thing that we saw, like errors that we defined in the previous lesson. Or you can throw an exception. But and at that time, I told you that the best way to handle the errors is defining some enumerator constants. And I said that many libraries are using the way, throwing exceptions to handle the error. And when you are using those libraries, you have to handle them. You have to catch them and handle them. But now I'm going to tell you for very small functions, you don't have to, or for functions that are very deep, you don't have to pass that in error variable and update that one and handle it like that. So for a very small functions like this one, you can, and it doesn't have any output. So this is just one function to print something, but it can fail if we enter a wrong score index. In that case, you can just handle the error by returning some true or false and saying that if it was successful or not, if this function has done successfully, has been done successfully or not. So here I'm just returning that one. And now I'm iterating over the items of the student list. And again, I'm using const reference because I'm not going to change them. And here I'm saying if the score index is lesser than the size of students, which is one pair of this one, and the second of that, it means the vector of float. If the score index is less than the length of this one, the size of this vector, okay, first show the name of the person, students.first, it's on pair, one pair. And now student.second with this score index. So as you can see, I'm checking everything. If I don't check this one and I use this, then I will have one exception. I will probably have one segmentation fault because this one is not at. If it was at, it would throw an exception. But with this one, it will not throw an exception. It will just give us a segmentation fault. And here, after this, I'm returning true. So it means that everything was successful. If you look at this one, when I'm calling this function, I'm checking if it was not successful with this one. If it was not successful, then I should handle the error. I will show a message to the user, or I will update my error function, error variables. So if you handle if you are making the user of your function aware of the error that is happening inside that function, you should also handle it here when your user is using your function. So these are the exercises. Are they clear to you, or do you have any question? If not, we will move to other topics.
I have a question in the loop of when you say if the score index is smaller than the student's second size, what do you do if it is bigger? Because then you would still return true.
The thing is that we know that we have students have a name and a list of scores, but some students, I mean, in this scenario, it depends on the what you are going to do. For here, I assume that people can have different number of scores. For example, you know, some students have two courses, and some other students have just one courses, or some other people have 20 courses. So the length of that scores are different for every person. So if it is not, if the score that they are, I mean, the score index doesn't exist for that student, I don't have any problem, because I assume that it means that that person doesn't have that score. But no, if it, I mean, in a scenario that all the students should have the same number of courses, then you have to here in else true return false, and I mean you should handle it like that. But it depends on your scenario. Is it clear?
Yes, thank you.
Okay. So let's move on to other topics. So the next topic that we are going to discuss about is reading and writing from and to files, and then parsing string. Sorry. We have two classes, OF stream and IF stream. Also F stream here, but mostly we will work with these two classes. The first class is a string class to write on files, and the second one is used to read from files. We have also some modifiers that helps us to change these classes. For example, I can use F string with these things, or I can use these two with this one. But the most common one are classes are OF stream and IF stream, and the most common modifiers are in, out, and up. What do they mean? In, we will open the file for input operations. With out, we open them for output operations. With append, okay, as its name says, all output operations are performed at the end of the file, appending the contents to the current content of the file. So if for your project you don't have, you're not going to work with binary files, you are working with text files, with some ASCII files, so you don't need this one. Actually, at the first time that I defined this project, we were going to work with binary files, but as the year passed, I changed the definition of the project. So for your project, you don't need this one, but sometimes you are going to, you know, in a real project, you will not have text files. I mean, mostly you will work with binary files. They are serialized in a way that people cannot read those files. I mean, it will be the serialization algorithm would be unique to your company, I mean, to the company that you are working with. But here in our project, we don't need that. So if you have a binary file, not a text file, then you have to open it like this, and you will work with every byte of that file, and you will deserialize every byte in your project. And when you are writing in that, you will serialize that. The other one is 8. It will set the initial position at the end of the file. If this flag is not set, initial position is the beginning of the file. So these are not something that's very important to you. If the file is open for output operation and it already existed, its previous content is deleted and replaced by the new one. Default mode parameter for this one is out, as its name says, and also for this one is in, and for these two it can read or write, so both of them are possible. So if you put or between them, it means that both of them are possible. So here I'm going to explain these things for you with some example. So we are writing in a text file first. These examples are created because last year, last year and the year before that, the students had to generate data by themselves. And these examples are very similar, very good example for them to be able to write a piece of code to generate those data. But you already have that data, so you don't need them. But these examples are still good examples to know how you can work with files, how you can read from them, how you can write in them, and how you can parse the strings, how you can generate random numbers. So that's why we are reviewing these examples. To generate some random numbers, we have different ways. This is out of the scope of our class, but this is the best way that you can generate some random number, because you know, if usually the random numbers that you have are pseudo-random numbers, they are not really random. So if you know the state of your PC at that time, you can regenerate that number again. But there are some other ways that you can that they use the one status of your hardware PC. One device in your PC, and based on that, they will generate random number. You don't need to think about this thing in very details. It's not something that's it's not something defined for this course, but this is something that is generating a real random number. So I get one device of my PC, and I define a default generator using that device. And I'm defining a random generator, which I said it should generate one number between 1 to 5. Okay, I'm going to use this random generator later on in this exercise. I'm going to write in a file. So I use the OFString class, and I open one file with with this path. Res is referring to the location. For example, I'm writing this piece of code in my main.cpp, and so main.cpp is my current directory. In my current directory, I have a folder named res, and inside that, I'm going to write in this file. So if this file doesn't exist, or even if it is exists, if it doesn't exist, it will create that, and if it exists, it will rewrite over that. So first, I open that file, and I check if it is open, then start to write in this file. And if it is not open, I don't do anything. It's not open. Again, it depends on your usage. So sometimes you may be okay with this one, but sometimes you may not be okay with this. And you have to show a message to user that, okay, that file doesn't exist. You asked me to do something, but that file doesn't exist. But in these examples, I didn't do that because, okay, it's just one example. I'm checking if it is open. I'm getting the current time, the current clock of my PC converted to the time of my to one time, I mean, it was first a clock and then converted to the time. And now I have the current time. I will change this current time, which is time t, to one string using ctime. Now at the end of that one, had one character that I didn't like to have. Actually, I can't remember now what was that because I wrote this exercise 2 years ago. But I think there was one character that I didn't want. You can implement this one yourself and check what was that character. To remove that character, I use this one with resize, and I change the size of this this current time, and this will remove the last one. Then, likewise, when you are writing in your console, you use stdcout, and here you have written stdcout, and you could write in that in your console. Now it's exactly similar to that, but instead of using stdcout, you will use your file system. You will use this file stream. So now you are writing in that. The first thing that I'm writing, time, one space, it has 5 characters. And then the current time str. And then one enter. So I wrote one line in my file. And it is very important to close that file. Why? If you don't close that file, you will still have that file. I mean, I think you have this experience. For example, you open one file in your PC, in your Windows system, for example, Windows operating system, and then you try to rename that file. Usually it says to you that the file is open somewhere and you cannot change it. So it is exactly similar to this. You are opening this file here in your program. You don't close it. If your operating system, as long as your program is open, no one can have access to this one. Even yourself, you cannot have the access to this one. For example, if I go out of the scope of this function in another file, in another class, and try to open, because I don't have then file stream there, I have to create another file stream or another OF stream there and open it again. When I try to open it again, it says that it will throw an exception for you. But if it was in the operating system, since operating system handled that exception, it will show you a message that that file is open somewhere. But for you, your program will crash because, okay, you're opening that. It might not crash if you check it again like this. If in that place, you again check that if that file is open, you will not, and your program will not crash. But the problem is that you cannot open it because you didn't close it somewhere else. So it is very important when you open your file, inside this, you will close that. Inside the if, you should close it. Otherwise, you will have problem. So till here, we have written one line in our text file, and it has 5 characters, one and the time of our current time, and one enter at the end. I can open it again. It's just, I could write this piece of code here before this close. But I wanted to show you, you can open, even if you close it here, you can open it again in the same piece of code. So I'm opening this file again, but now if I open it without anything, without this modifier, it will overwrite that. So it will delete that file and overwrite over that. But I don't want to. I want to append to the end of that file. So I have to use this modifier to append that file. So if you have a file and you want to append to that, you should open it with this OFS stream, but with this modifier. Again, I check if it is open, if I have it. And now I'm going to write something inside this file 10 different times. But what are we going to write 10 different times? One line. How can I create that line? So the first thing that we have, I'm using that random generator to have one number. It will give me a number between 1 to 5. So I have this one in the upper limit. Now I'm iterating from 0 to that upper limit. For example, it was 4. Okay, the random generator gives me 4. And now I'm writing 0 till 4 with 1 comma and 2 spaces in my file stream. I didn't put int to the endl. I didn't put, add enter. So the line is still continuing. So the line is not completed yet. After writing this line, I use the random generator again for another number. For example, it will give me 3. Now I'm going from 0 till that 3, and I'm adding those 0 till 3 with, and I separate them with underline, adding them to the same line because I didn't write here std_endl. So we will have 10 different lines, and in every line we will have some values that are separated by comma, and we will have some values that are separated with underline. And all of them are adding to the same file. So we will have 10 different lines, and I will close it here. Now I'm going to read this file and parse it, not just reading. I can read the whole file in one text, one string. But I want to parse it. So I open it with ifstream, and I call it with, I call this function again. This function to open that file. And I'm creating a container to store those values that we just added to our file. The container that I use is vector of vector on-site short. Why? Because I only added the value between 1 to 5. The random generator gave me 1 to 5, and I added the value between 0 to one of these numbers. So this is on-site short. So it's not, all of them are positive, and it's on-site short. And I want to have 10 different, I had 10 different lines, and I want to have the elements of every line in one separate vector. So at the end, in info, I will have 10 different, I will have one vector of 10 different vectors. And every vector inside that have those values, j, that we entered here in this file. Okay, how can I do that? First of all, I know that the first line that we entered was current time. It was not those things. I'm aware of the structure of my file, and based on that, I will try to read that file. So I created one variable with line here. I get, using this function, you can get one line from your ifstream. It will write that line in your string here. As you can see here, I want to only read the current time str. And if you remember, here, the first thing that I entered was time equals, colon and space. So I'm going to remove this one. So because of that, I use substr. It will give me the line now includes the whole line in that file. I mean, this variable has the whole line, but I don't want to have time, colon, and a space. So I'm saying that give me a substring from line from the location 5 till the end. So as you can see, for every element, every container that we have, a string is also a type of container, we have some methods. So you can work with those methods. Again, we cannot cover all of them in this course, but you can use them to be able to parse them. One of the most common one is, for example, substr here. So now I have the current time in this string. Now I'm going to read the rest of the file, and I'm aware that the rest of the file are those lines that we added with that random generator. So again, I'm saying that till there is something, there is one line, read this, continue doing this fine. While we have a line, read it and write it in the file, in the line, in this variable. As you remember here, when I was adding these values to this file, I also added some spaces, but I don't care about these spaces. I only want those values. So for every line, I erase those spaces from my string. How can I erase that? I have one function, again in a standard templates library, which is remove if. Similar to other functions that we have in a standard template library, we have an iterator, a pointer referring to the start of that string to the end of that. If it is a space, remove it. And what does it do? It says that it will give us a pointer to the all spaces, but it will not erase them. We have to use line.erase to erase all these elements that we found from line till the end of the line. So if you want to erase all the spaces, this is the whole command that you have to use for that. So now my line only every line is consisting of some values, some on-site short values, which are separated with comma and underline. But they are not still on-site short. We are still working with the strings. Okay, so first I should split these every line, these values with those delimiters. So the delimiters here for me was comma and underline. So I'm saying that I'm using this split from Boost library. So if you want, you can use this. If not, I think probably in the compiler version 20, you will have this one also in the standard template library. I haven't checked that, but you can check it. If you have it, you can use it from there. If not, you can add Boost library to your project and work with this Boost split. If not, you can find in Google and try to find a better option instead of this one. So with this one, we can split that line and write it to a vector of a string. Every part of that would be a string, and it will be stored in the vector of a string. And I'm saying that you should separate this string with any of these things, if it is comma or it is underline. But this one, if you, for example, have sometimes bootstrap also, I mean, this is a problem that we have with bootstrap. It gives you some empty strings. If you Google on that, you will see a very good function that people has implemented, that they remove those unwanted empty strings, but in a very optimized way, not just having a for loop. So you can use that one, but you should be aware that it will may lead to some empty strings, because you may have two delimiters without having anything between them. So then you will have some empty strings. So till here, I have for every line I have the numbers. But as you saw here, I want to store them as on-site short. So now I have to convert those strings to some on-site short. So I iterate over them, and I'm not going to change them directly. So it's const reference. I write here a try catch, and I use boost lexical cast to convert that item to that on-site short. And if it is converted, then I will push that one to line values. The line values is just the vector of that on-site short. But it might not be converted. For example, you may have something not a digit. I mean, you may have some other things in your file. Then that string may not be converted to on-site short. In that case, you will have an exception. So when you are using something, as I said earlier, you have to check its documentation in that library. If you go, for example, for the documentation of this library, this function, you will see that it says it would throw in a bad lexical cast exception if it cannot convert that item. So in that case, I use try catch to catch that exception, and I'm handling the error here by just printing that one. So maybe for you it's not like that. It depends how you design your program. It's just one example. But why I'm using lexical cast here, I will explain it that in the next slide. But before that, let's complete this part, and then we go here to discuss about this. So I push back every value to line values, and then at the end of this run of this file, I will add these line values to this container, to my final container. And here, if it's open, I'm closing this file stream. So now I have all the values in my container. I read all of them from this file. But the question is that usually, if you are familiar with C++, you probably have seen that to S2I to convert one string to integer, for example. So why I'm using lexical cast? Look at this one. I have int value 0, and I have one string. If I try to convert this temp to integer, it will throw an exception because it's just an empty string. So it's okay, it's very good. We know that. I mean, again, it depends on your the scenario that your usage of your program, but usually it's like that. Usually you want to have an exception if it's just an empty string. You don't want to convert an empty string to an integer, so, or a number. So in that case, it's good. We handle this exception. We know that, okay, something happened. But how about this one? It's 12 thumb. Again, probably I don't want to convert this one. It means that my split was wrong. I mean, something wrong happened before this conversion. Usually people don't want to convert 12 thumb to integer, so probably the input is wrong. But if you use s2i temp, it will return 12 to you. So it will not throw an exception. It will give you the part that it can convert to integer. But if you use lexical cast int, it will throw an exception. So that's why I'm using this one. And if I use Tom, for example, both of them return an exception. So that's why I'm using lexical cast here, because I really want to be sure that I will have one exception for this type of input. Why I'm using exception here, because Boost lexical casts are getting inherited from std exception. So any exception that we have are getting inherited from a std exception. So in this case, if the exception happens from this one, which are two different types of exception, or from this one, which is a bad lexical cast exception, both of them can be catched by this. You won't have such a thing. You won't have these two. It's very rare to have a 2i and also lexical cast in the same piece of code, but it is possible that you will use try catch for two different types of or more different types of things. So if you write here, for example, 3 dots, it will catch all of them, and it's not really recommended, and I explained before why. And but the problem with that one is that you won't have any access to that exception to print the message of that exception. Again, it's not really recommended to use such a thing. It's better to be very detailed with your exceptions and use something like this one. If you know that the type is bad lexical cast, you should use this one. Otherwise, you will catch. You cannot handle it. You won't know that if this exception happened because of this command or it happened because of the other command. You cannot handle it. So we have learned about reading and writing from files. Do you have any questions? If not, we are moving to another topic. Is it clear?
Yes, I think it's clear.
Okay. Okay, some other thing that you have in Boost library, and I also checked that in compiler 17 of C++, I mean a standard compiler. You also have this thing in your library. These are the things, Boost paths are really useful thing for you, because C++ by itself, by its nature, is a cross-platform language. It's not like, for example, C# that you can use it only for Windows PCs. It's similar to Python. You can use it for on Linux or Mac or other operating systems. But it's also important that you write your program such that it can be cross-platform. It means that cross-platform means that it can be run on on different operating systems. For example, you know that in Windows we have different way of defining the path. and from the type that we have in Linux. You can, if you want to, okay, let's see the example and then you will understand it better. I'm here creating an object of type path. Now I'm with this one, I'm getting the temp directory path. The temp directory paths on Windows and also on Linux are different. That their temp are different from each other. So, but Boost file system is giving me the correct one, no matter, I mean, regardless of the operating system that I'm using, it always gives me the correct temp directory path. So this is one advantage of using Boost path. As I said, if you are using the newer version of C++ compiler, you have the same one in standard template library, and it's better to use this one instead of this if you are using this compiler or a newer version of that. But now I want to, for example, here to create a file in this temp directory or not. I may have this file in my temp directory, but what can I do? If I, for example, convert this Boost path to a string and write, do the concatenation with /example.txt, then I may not have a problem with in Windows, but I will have a problem in other operating systems. So it's not really good. What we do is that we use this path. This is one path. This is a path object, and I use this one and the name of that file. So depending on the type of the operating system that your program is running on, it will substitute the correct delimiter for your path here and create a new path. From this path file, path object, we have some methods, some very useful methods, like this one, for example. I can get the parent path of this one. I can get the name of that. I can get the extension of the file. So this is really good to work with either Boost paths in the file system of Boost or in the file system of temp, a standard template library. It's not really good to work with paths with the strings objects. You should work with path objects to make your program cross-platform and avoid any potential bugs. If you may think that, okay, why we are using Boost here when we have all these things in a file system, I should say that, you may guess that till now, that in the past, in the previous version of C++ compilers, that many people are still using that, like C++ 14, we haven't had these things in that, in a standard template library. So we had to use Boost library, which is not part of the standard C++. It's an external library. But as you can see, all of them are, not all of them, but most of them are gradually added to the standard template with the same name even. So in this way, people who have written their code in C++ 14 and they have used Boost library, and now they are moving to a newer version of compiler, the only thing that they need to do is that to replace Boost in their project with std. But again, this is really important, and you can see the effect of writing this to here. And now I know that this one is coming from Boost, this one is coming from STD. They have the same name, and if I don't write this, it may lead to, it will be very ambiguous for the user of your code, and it may lead to some bugs. So this is the way that you can work with paths. The next topic that we are going to discuss about are regular expressions. We don't have time to discuss about them in depth, so but they are not really difficult. They are actually part of a course that I'm not sure you had it, but this is not really difficult. Actually, regular expressions are a tool for you to make writing your program easier. So it's not something to make your project more difficult. Don't consider it like that. This is just really a good thing that it's really good to learn that. Otherwise, you have to implement many things by yourself. So what are they? A regular expression is a sequence of characters that define a search pattern. If you Google, you will find many online tools to learn, build, test regular expressions. Let's go here, for example. Let's bring it here. Can you see my browser?
Yes, we can see it.
Okay. As you can see here, there is a cheat sheet, for example. So you can work with this one easily. I mean, it's explain everything here. And where you can use it. For example, you know that your comments has some well-defined structures. So you can use regular expression to parse them. But I'm not going to solve them here for you, because then you will not have much to do. So I will give you another example to just work with them. For example, I have, let's give you one example. Delete name, what else I can name, read name. No, it will be very similar to your okay. So now I have this one. This is my command, and it's deleting two two values. I want to, from this command, to extract Nastaran and 123. How can I write an expression for this one? First, I know that this is delete. I don't need this one. And the next one is a name. I will write W plus and 1 comma space, and I will write D plus. You can see, you can easily work with this one, and it's giving me a match here. And it says that the group 1 is Nastaran and the group 2 is 123. What I'm doing here, what am I doing here? So first, I'm saying that I have a string. I want to find a match to that, and I want to extract some items from that match if that match happens. So for this one, I know that this is the names are just some characters. I mean, it would be better to, instead of write this one, I should write, for example, A till Z and A till Z. This one. Why? Because W, this one, is it can be matched with word, digit, and white space. But I don't want the white space. I want to have only the characters between A to Z, the capital, and also sorry, the lowercase and uppercase of them. And I'm saying that it can have it should match with at least one character or more than this. Okay, and what these braces are saying, it says that, as you can see, any of the characters between these two. But what these plus is saying, I think it's also written here, plus is saying one or more characters. Okay, so by doing this, I mean, from here till here, I'm saying that find a match with a piece of this string that has characters between A to Z, either they are lowercase or uppercase, and at least it should have one character. And what these parentheses are saying, it says that make that as a group and return it to me. If I don't write this one, I will have a match, but as you can see, I will have only one group here. I will have one group because I only have one group here. So it will only tell me that there is a match with this piece of the string, but it will not extract nestan for me. Okay. What this one is doing here, it's only match with any integer character. As you can see, the online tester is giving me the hint. There is a tooltip for everything, and you can use either this cheat sheet or this one to solve it. Sometimes you need to use one parenthesis, for example, but you don't want to have a group. So, for example, you want to use it. Okay, I will say it in another example because it would be confusing to you. So here again, if this one is another group, it will be matched with this one because I'm saying that it should be integer. If I put here, for example, D, as you can see, D is not in my match. Only this part has matched with this regex, because I didn't write a D here. If I put, for example, D, it will be matched. If I put, for example, W, it will be matched, because W, it says that it's either a character or a space or something else, a digit. What else we can say from this example? So I think we cannot cover all of these things here, but you just need to read these things and work with them. But the only thing that's maybe useful to you to know, for example, I'm saying, I put here one space, okay, and there is one space here. But if I put more space, then I do not have any match. So if you want to ignore the matches, the spaces, you just put here /s, any white space will match with any white space, and you put this one, star. Star is that either there is a space or not, it should be matched. So if I do not put any space here, there is a match. If I write many space, it will be matched. The other thing, if I want to have, for example, I want to write here the names that are started, for example, with either N or A, for example. No, either J. let's write it like this. I'm saying that there is, or it should, the first one should be either A or, okay, with this one again, I can use this, but what can I do? Oh, okay. The first one, for example, it should be started with JO or NA, and I don't want to capture this, and the rest, and I want to capture. Okay, I think this is correct now. So what I'm doing here is that I'm saying I want a match here. Okay, the thing that I want a group here. You see, this is the group. We have two groups. For this one that is inside this, there is no group. I mean, it's not a capturing group. It's a group, but it will not be captured because I'm using this notation before that. Okay, but what is it's saying? It's saying that the name should start with J, O, or NA. For example, if I write here, there is no match. It will not be match. You see? So, but if I write, for example, here, it is match because it started with J, O. You see, it's very useful tool for you. And if you are familiar with Python, many people in Python are using this. Maybe in C++ is used less, but it's very useful. You can use it for your comments and make writing your program much more easier than you can imagine. So, but you can read this one. These are not really difficult. You can learn them. For example, this one is non-capturing group that we just said. This is the capture group that we saw. This is the we saw a star. We saw plus here. We saw also this one here, character between these things. We saw /s here, WD. So you can work with the rest. They are also useful topics. But let's see how can we work with them in C++. So with Regex, with this one, you can work with regexes. You can try to see if you are writing a correct, if you're defining a correct regex or not for your program. But to work with, the expressions, in C++, you should create a regex object with that regex that you created here, for example, or you can write it here. I'm just giving an example, sorry. And since we are in C++, for every slash, which is a character that it has defined for, has a definition for your program, for your language, you have to add one extra to escape that character, but it doesn't mean it's exactly /w. So here you see I have one. I'm saying that my regex is any character or digit, and it should have at least one. And I'm saying that it can have some other words. The words are consists of digits and characters and also spaces, but they are separated with comma. And I'm saying that there might be such a thing at the rest of the string or not, 0 or more. So my string is this one. It can be any other thing. I want to have the match results in CM. In newer version of compiler, you should surely check that. Maybe in the newer version of the compiler, you need to use another structure here instead of this pointer. But at that time, I had to use this one. But as you can see, when I see a standard pointer, I think with myself, can I use a smart pointer? So you should also think about that like that, because they are much safer than using a standard pointer, even if I'm not taking any memory from heap memory here, but it's better to use them. So I'm calling this method Regex Match, and I'm saying that I want to check this string as a char string. So this will give me a pointer to this array. It's like a char array. And I'm saying that I want to have the results in CM, and the regular expression is this one. And the results would be in CM. I will have a for over the items of the CM, and I will write them. The first one is the whole match, okay? And the second one and the third one are the groups that are matched with this one. So the first one that is matched with this one is AA, this one, and and the last one, which is here, not this one, we are not capturing this. What we are capturing this one is DDD. Why? Because for this one we have a nested match. So, and the last match will be matched, will be returned. You will have other functions in Regex that you can find all of them. Check for that and see if we want to just find all of them. Instead of writing this, you could only write. You can erase this one and write this one and call another function, which is not Regex Match, which is in Python we have find all, for example. I can't remember now what is the name of the function in C++, but probably you will have also such a thing, and you can search for all the occurrence of all the matches of this regex in this one, and then you will have all the matches. But if you use this, it will only, for this one, it will only give you the last match. Okay, I have written here. So for this one, I couldn't remember that I written it here. Okay, so the answer, you have it. You don't need to search it for that. So for this one, I'm searching this, and in this one, and I will return all the matches. I'm creating a Regex Iterator, so it's similar to find all in Python. I'm iterating over this one from the beginning till the end, and the expression. Okay, this comes from, okay, the both are coming around. Okay. These are the newer version of them, and at that time I was working with the old version of compiler, and when I was creating this slides, I Googled over that and I found this answer, but I couldn't remember it. Okay, you will iterate over them and find all the matches, but to see this one, you should iterate from this one till the end of that. And with this one, I'm checking if it is the end of that. And I'm sure with this one, I will give me one match, one string match. And with this method, I'm getting that string. I'm getting a string of that match, and I'm printing that here. So you can also do this one for your comments. They are very useful. Use it. I mean, you can, to ease your life. Okay, if you have any question, you can ask. Otherwise, we will go to other topic. Oh, is it clear?
Yes, I believe it's clear.
Okay. So am I in the correct one? Yes. Okay. So the next topic that we are going to talk about are classes. So now you know many things. You know about the standard template library, about pointers, about functions, if else, switch cases. You know many things. But the main thing that you usually use in C++ are classes. So what is a class structure? Class, to create a class structure, it's like a template that you can create some objects, and those objects have some member functions and member data. Till here, we're working with different data, different data with different types of data, like the containers that we saw from the standard template library, or the standard or the fundamental data types like int, float, and so on. But you can also create your own container, and that's one your own data structure. And to do so, you can use class structure. You can also use other struct, but this is out of the scope of this class, and classes are more common to be used than struct. So to create that, we have class, and we use the camel case format of naming, style of naming conventions, with the capital letter, and the next one also capital letter. Public, protected, and private. The default specifier for that is private. And what does it mean? It means that if you define a member function or data as a private, you can't access to them using the instance of this class. Let's say it like this. We have a class, and we can create an instance of this class. Through that instance, we can only access to the public member of the class. We can't have access to the private members or protected. While we are in this class, we can have access to all of them, all the members and data that are defined in either protected or public or private. But if we are in a class that is inherited from this class, we can only access to public and protected members. Again, it depends. If you get inherited from one class as public, if you have public inheritance, then what I said is true. Otherwise, it's not 100% true. I will discuss about inheritance in the next lesson, but just to let you know, protected is used when you have inheritance. When you are getting inherited from one class, you have access to the public members and protected members, but you don't have access to the private members. If you have an instance of a class, you only have access to public members, not protected members. And if you are inside that class, inside one of the members functions of this class, you have access to all of the members of this class, regardless of the type of the specifier that is used for that. As I said in the previous lessons, we put the declaration of classes in a header file and the definition in a source file. You are already familiar with header files and source files. I gave you one example in Visual Studio when we were working I think in the third lesson, I showed you how you can create a header file and how you can create a source file. At that time, we use it for creating functions, but now you should work with classes. But let's see how can we define a class. This is just the declaration of my class. Like functions, we have declaration and definition. Again, here we can have a declaration and definition. I have class human, public, private, and a default one is private. But I need one constructor to create an instance of that class. And that constructor must be public to be able to use it. What is a constructor? A constructor is a special kind of class member function that is automatically called when an object of that class is instantiated. So here, look at this. I have one private member, m_id. I have one public constructor, string ID. The definition is not written here, but okay, imagine we have the definition as well. And inside the definition of that human, I will assign this input to this data member. When I call this class, it will call the constructor of this class with this data, which is string, and it will assign it to its member. Using HM, I cannot have access to m_id because it's a private member. And so I have two different ways to create an instance of this class, either using equals or using this one. I can't call it like this because there is no default constructor here. But let's see what is a default constructor. A default constructor is a constructor which does not take any arguments. So if you have that default constructor, then you could call it like this. Otherwise, you can't. Like here, you don't have any default constructor. You have one constructor that gets this data. This variable as the input, this argument as the input. But here I have a default constructor, as you can see, and the definition of that is written here. We will write this one in a header file named human.h, then we will write these two in a CPP file named human.cpp. The name of the files are all lowercase. They are snake case. I mean, you will use underline between them. So if you have, for example, class name, like here, let me show you. If this is the name of your class, the name of the file should be class underline name, and all of them would be lowercase. So here, with this declaration and definition, I can call it like this. It will create an instance of this class for me. Even if I don't write these two here, this one is constructor and this one is destructor. I will discuss about destructor in the next slide. But even if you don't write these two here and you write just this, it will create for you the default constructor and destructors. So if you do not declare any constructor for your class, C++ will automatically generate a public default constructor for the class. Okay. These are not the only thing that that the compiler will create for you. You will also have copy constructor and assignment operators. If you do not define any copy constructor for your class, the compiler defines a copy constructor for your class. And if you do not define an assignment operator for your class, the compiler defines an assignment operator for your class. But what are they? This is just a constructor for my class. I created a class that I can write, as I said, the declaration of the class is in this .h file, in my header file, and the definition of that is in my CPP file or my source file. But for some members that we only have one line of code, it's very just one command, for example, or two commands, and which can be written in one line. Then you can write the definition of them in the .h file, in their header file. For example, here, the only thing that I had was just assigning MID to MID. Okay. In that case, the definition is written here next to this declaration. But for this one, this is a constructor. This is a copy constructor, and the input of that is another instance of this human. And since I'm just going to copy this one to this human, it's a const reference. How it is implemented here in its definition, and I'm assigning human.mid to MID. What is the assignment operator? The assignment operator is, its declaration is like this. Again, similar to this one, it gets human, but it returns a reference to human. It has this name operator, the assignment, and it's defined like this. So it will return a pointer to this object. I will update this one and with the items of this, and it will return a pointer to this. For your project, you won't need this copy constructor, and you won't need to write this copy constructor and assignment operator, but you should know that they are already implemented for your classes, and sometimes in some projects you may need to change them. If you change them like this, you will override the default copy constructor, and you will have your own copy constructor. But when they will become, how we can call these two? If I write something like this, imagine it was human, for example, the class name and a variable name, it will call the default constructor because it doesn't have any input. If I write something like this with another class object, this is an A is also of the type class name, B is of the type class name. This one we call the copy constructor. If you assign two objects of the same type, this will call the assignment operator. So this is something that you will use, but you won't implement it yourself as long as you don't want to change it. But they exist in there for you. For your class. You are familiar with overloading. You know that in overloading, let me ask you, do you remember what was overloading? You can also see the examples here.
Overloading was the use of the same procedure with just different parameter types. We saw it to introduce templates, which are much more effective than just having, for example, a summation function for both integers and floats, and then naming them the same, and then just having different parameters but doing exactly the same?
You're kind of correct, but yeah, for the scenario that you said, templates are better, but it doesn't mean that overloading are not useful at all. So overloading are also useful when they are doing the same functionality, but their body is different from each other. For example, here, I'm overloading the constructors. Both of them are creating an instance of this class, but the way that they create an instance of this class is different from each other. In that case, I can't use template functions because their body are not the same. If their body is the same and just the type is different, then we will use templates. But if their type is different or the number of arguments are different from each other, but their body also is different from each other, but they are doing the same functionality, then we will use overloading. It means that we will have a function with this, two or more functions with the same name, but with different arguments and different bodies. So this is what we do for my classes. You can see here I have 3 different constructors. Constructors are just some functions. We can overload them. So I'm saying I want here a default constructor. So no matter the user inputs anything or not, it can, the user can create an instance of this class, even if it doesn't, he or she doesn't enter any value, any argument to this class. So I have this constructor. The body you see is different from these 2. The other one is the user can create an instance of this class by ID. And if it enters ID, I will assign MID to that. The other one is that with ID and age, it can create also a human object. And it will assign the variables. I will explain this one later. But something that I want to say here, you can let your user to create an instance of your class in different ways using different constructors. But again, it doesn't mean that it's very good, it's very fancy to let the user to create in very many different ways. No, it depends on your scenario. So sometimes you may even want to make your constructor private and doesn't let your user to create an instance directly from using the constructor. But sometimes you, depending on your scenario, you may want to let user to create multiple, to have multiple ways to create an instance of that class. So again, it depends on your scenario, but you should know that you can create, you can overload the constructors. But what is the difference between these 2? So if you only have, these are again in the definition of the class and in my CPP file, and this one is in the header file. Since we are just we don't have anything. These are just some assignments. If you only have some, you can in your constructors you can do some process even. It's not. It doesn't have to be just for assigning something to another thing. It can do some other thing. It can write in a file. It can do some process. It can update your GUI. It depends. It's not always like this. But for assigning the variables, the data members of your class, you can also go for this way. You can either assign them inside the body of that constructor, or write one column and then assign ID to MID, age to age with comma. They are separated with comma. So these are, I think, the things. Something that I forgot to say. As you can see here, for private member, I'm using M_ID. For public members, I'm using uppercase, camel case. For members, I'm using snake case. So these are the naming conventions that you should follow, and I gave it to you when I was defining the project. What are destructors? Destructors are the things that clean up your objects and free any resources or memory that you might have allocated, either in the constructor or throughout the lifespan of your project. If you remember, when I was teaching, when I was letting you know about pointers, I told you that we get memory in the constructor and we erase them and delete them in the destructors. So this is the destructor, the thing that we discussed before. A destructor always has the same name of the class, like a constructor that has the same name of the class, but it is preceded by a tilde. Destructors can take no arguments and have no return value. And as you can, this is the, okay, let's first this one. This is just one class. It has one default constructor. It has two values. We have another class. It has a member of, as you can see, of this one. It's not really good to use a standard pointers here. The reason that I'm using a standard pointers here, that in the previous years, I first taught classes, then I taught smart pointers, and at that time the students were not familiar with smart pointers, and because of that I used standard pointer. But you should not use it. You should write here, for example, shade PTR instead of this one. And then I have a default constructor here. As you can see, a class can have a data type of any other data type. It can have a data member of a type of other classes or other template classes, or it can have template functions. You can have all the things that you learn till here inside a class. In the destructor of this class, what I'm doing here is that if it is a standard pointer, it should be deleted, because I haven't wrote the constructor here, but probably in the constructor, for example, this one, I'm getting memory from the heap memory. Then in the destructor, I will iterate over these pointers and I will delete them, set them to null PTR. So this is really important. When you in the first part of your project you don't need, but in the second part of your project, when you are working with Qt library, you probably would use a standard pointers. So to check your files, you will, when you are writing your destructor, you should go to definition, to declaration of your class and see if there is any pointer there. You should delete them in your destructor. Let's see how much time we have. Oh, 2 minutes. I want to reach to a good point, but let's see, static variables. Okay. This is the only things that remain. Okay, I will explain this one, but the static variables will remain for the next lesson. But you can read it also yourself. It's just 3 slides and some examples. You can write these exercises yourself, no matter if I talk about statics, because you don't need them for those exercises. But let's finalize the lesson by this slide. You have here I have the human class. Here this command we call the default constructor. This one will add, since I said that it's a private member from the instance, I don't have access to this private member. How can I access that? By defining two public functions, setter and getter for them. If I want to set them, I write a setter for them. If I don't want to have a setter for that one, I don't write it. It depends again on your scenario. You may, for example, assign it in the constructor, and you don't want you don't want to let your user change it after its creation, and you are the only person who can change it. In that case, you won't write a set age, a public setter for that age. But here I wanted to let user to set the age after the creation. So then I created a public function, and I have access to that public function through this instance. And when I call set age, it will assign age to mage. I can also get that mage using that getter, get age, which I created here. And as you can see, since they are just one line of code, I wrote these definitions next to their declaration, and it's better do it like that if it's just one line of code. With this one, I'm creating an I'm getting from heap memory a location of type human, and I store it in a standard pointer, the address of that location in a standard pointer of human. And to access that that member function, I use this operator. But again, I can conclude here, only provide access functions when it makes a sense for the user to be able to get or set a value directly. Because you may implement some algorithm in your classes, and you may need some private functions, private data members, or private functions, but it doesn't mean that you should share it with the user of your class. It's just you only share the things that the user really needs to work with that. Okay, if you have any question, you can ask. Otherwise, we can do some lesson now. No question? Okay. Have a nice day, everybody.
You too.
Bye.
Bye.